Hello everyone, this is Bharat here. Welcome to my peer graded assignment for the course Managing Machine Learning Projects under the AI Product Management Specialization. So let's get into the project. So the project here is we need to pick a problem area which is in our industry or in our area of interest, and we need to see if there is any opportunity for machine learning to help help the problem, help solve the problem. Now, as part of this project, there are 5 things that we need to be taking care. We should evaluate the opportunity. Then we should have the DM business understanding applied to this project. Explain the solution validation plan. Explain the system design using machine learning. And then also highlight on any potential risks in production for this particular project. So let's start with the first step, which is the opportunity evaluation. So here in my project work, being a product manager myself, I have opportunity to work in different product lines. One of them is cybersecurity. And the problem area I'm picking here is around the vulnerability assessment and remediation, where the product that I am working on, currently it performs scan of assets, it generates scan reports, and it sends the scan report to the administrator, highlighting the vulnerabilities in an organization. And then based on the report, the administrator takes the remediation action. Now, with this current behavior, there is a lot of manual work involved for the administration specifically. They need to analyze the scan report. They need to see what are the real vulnerabilities, ignoring the false positives, come up with remediation scripts for different types of assets or different types of environments. All these are time consuming process considering it is all manual. The solution I can think of here is leveraging machine learning to modernize the vulnerability management. So if given the abundance of rich and historic data that we have with our scan reports, the multidimensional risk elements and brute force approach to remediation, the vulnerability management field appears ripe for AML exploitation. Uh, so having said that, uh, getting into the opportunity evaluation. So there are 3 areas or 3 criteria that we need to evaluate for identifying opportunities. We need to understand if there is a real problem. Number two, if we can see if ML can solve it. And even if we can solve it, number three is we should see if there is someone who can care for the solution. So starting with the first step, which is there anyone is there a problem? So I have myself being a product manager, I have listened to a lot of users, my customers, my peer workers, IT administrators, and have clearly heard myself from these folks that there is a problem in handling the vulnerabilities reported by scans done by the vulnerability management tools. So if you look at the scan reports, they are very huge in case of vulnerability assessment, and the manual work is not easy in this particular space. And if you also look at the results that we are getting, we should observe them in a context. Uh, we should only look at the vulnerability specific to the environment, not just everything. So there are a couple of problems that I can highlight here. If you see under the problem section, so I have put here. Number one, there is a risk score that is associated with each and every vulnerability that we have, which we call it CVEs. So there is an online database where all the CVEs are maintained for each and every vulnerability that is reported. Now, the scoring mechanism for this vulnerability can be improved. Like, for example, there might be a vulnerability that is reported as a critical or a high in the online databases. But considering your environment, then the vulnerability might not be a critical or a high. So there should be a context sensitive evaluation of the CVEs. This can be achieved with the help of ML. And also, if you look at the remediation, which is it is the second problem we have. We should evaluate all the vulnerabilities. We should come up with a remediation solution, and above all these should happen in a almost real time, in a very minimal time frame. And the remediation is a very painful activity again. So we should see if we can have this remediation activity done at a quick pace. So ML can again help here with the historical data. So definitely there is a problem here, and can ML solve it? Yes. So with my understanding of ML, thanks to the Coursera course that we are going over, and also with my understanding of cybersecurity space, I, I am pretty sure ML can help with solving these problems. Like I said, the two problems that we have, having a context sensitive CVE scoring. This can be achieved with the data that we have with our past scan reports, where we can look at our environment. We know how our environment is structured, our infrastructure. Look at the environment, what kind of machines you have, what kind of operations are happening, what kind of users come in, what kind of requests are happening in your platform or your infrastructure. Compare it with the vulnerability reporter and see if it is really applicable for your environment. That should take care of the problem one. And when it comes to the remediation by itself, again, you have the historic data, scan reports of past few months or few weeks can help you in getting the remediation. You can figure out common problems that are getting repeatedly reported in the scan reports, and you can apply the same solution that you used in the past. So that way ML can help here as well. So now is it worth solving the problem? Yeah, definitely. So this can help in many ways. Like it can help the administrators reduce time in evaluating the scan reports, coming up with the vulnerability solution, the remediations, and also getting rid of the false positive. All these can be helpful for IT administrators. And if you look at organization by themselves, vulnerability is a very critical space. Anything that is vulnerable and if it is out in use, that is going to take a stack on the company's reputation, and it also going to be a big financial loss if it is a very critical one. So considering all this, there are people definitely waiting for it. And if you look at the graph that we have, which is plotted against the business impact and feasibility, like I said, there is a very high feasibility that this can be implemented with ML, and also the business impact that it brings in, the solution that it provides is highly helpful. So it's a very optimum solution to build, considering the criticality. I'm moving to the next step. Before getting into this next step, so just a quick refresher on the CRISP DM. CRISP DM is a framework or a process that can save as the basis for data science processing. It has 6 phases: business understanding, data preparation, modeling, evaluation, and finally deployment. For this project, our scope is only restricted to business understanding. So getting into the business understanding phase here. So here in business understanding phase, our aim is to focus on understanding the objectives and requirements of the project. Here we'll be doing it in 3 phases: defining the problem, defining the success criteria, and then identifying the factors. Starting with the first one, defining the problem. So here the target users, if you look at it, it is going to help CISOs, IT administrators, and cybersecurity professionals by reducing the remediation time and also helping in better CV scoring. And the problem, like I mentioned, we have 2 problems here. One, we need to have a context-driven CVE priority for vulnerabilities. And number two, a remediation plan, a concrete and remediation plan, which can be deployed in a very quick manner. Why it matters? Any breach or any attack environment can lead to a significant impact, like I mentioned earlier. Organization might need to pay a very huge ransom, and also it can lead to the credibility of organization getting into your stack. So the current state is, like I said, administrators run the scans on all the machines in an environment, get the scan report, do a manual evaluation in most of the cases, detect any false positive, get rid of them, and then finally come up with the remediation scripts or fixes. So this is a manual process that's currently used. And what is going to be this success here? The impact, it is going to be like improving the remediation time and minimizing the false positives. Metrics that is mainly concerned here, if you look at the outcome metrics, it is reduction of the remediation time, and output metrics that we are going to consider here is MSC for aggregate predictions. And targets, again, the outcome is going to be reduction of the average remediation time by X minutes in 5, and then output is going to be MSC less than X's. And constraints here, the prediction must be delivered in real time because it's a security vulnerability. And the factors that are implementing, there is a significant manual work involved, like I said, that is going to be a very big factor. And then there are a lot of false positive irrelevant for your organization or your environment that needs to be removed. So that's a second factor. Now, what is the solution or plan here? So before I get into the plan, the solution here is to use the ML to use the past scan data, understand the CVE scoring, use the past data to understand your environment, link both of them, and then see if the CVE scoring, whichever is provided by the online governing bodies, is really applicable to your environment. And also use the past historic data uh, to fast track your remediation process. Now here we are going to have an agile approach to ML, where we are going to explore the hypothesis, build it using more of the CRISP-DM each time, observe it in action, get the feedback, and analyze the results and repeat the same. So here, if you look at, we are going to get into an iterative based approach. We have like 4 iterations here. The first iteration is mock-up of the potential solution, which corresponds to the business understanding phase of CRISP-DM. Then we have the phase two or the iteration two, where we have small set of historical data and a mocked up model build, which will correspond to the business understanding and data understanding. Third step is going to be a use of real data with a the model, and it corresponds to the business understanding, and data processing phases of CRISP-DM. And the final iteration is going to be using a real data on a simple ML model, which corresponds to the business understanding, data processing, and modeling phases of CRISP-DM. So for each of every phases, like let me start with the first phase, which is mockup of potential solution. Here we are going to create a simple mockup of our solution, deploy it as a first iteration and see the results. Just to understand the requirement here. Once we are satisfied, we get into the second phase where we use a small subset of historical data and a mockup model. We get the results. We get into the phase three, which is a slightly different approach where we use a real data on a heuristic as a model, and then we understand the results here. Finally, we use a real data and a simple model. Coming to the fourth step here, the ML system design. So the system design, it helps in deciding the impact with the choice of technologies. So like we have 3 different areas where we need to consider the system design. Number one is whether we need to go with cloud or edge. Number two is whether we need to get into offline versus online learning. And number three, whether we should go with a batch or online prediction. Now, here for the project which we have, my conclusion here is starting with the cloud versus edge here. So since we are going to have our predictions or the models running on the target and the scan is happening on the edge devices or the endpoints, our conclusion here is going to be like a edge. And then in case of offline versus online learning, our solution is going to be using past scan history. So we can have some amount of work already done before the scans and have it ready and apply it when the time of scanning. So offline learning is going to be a preferred approach. And then when it comes to batch versus online prediction, we are going to go with an online prediction because as and when scan reports are generated or a vulnerability is detected, we need to immediately predict online on how the vulnerability is going to be. So for our case, uh, it is going to be like an edge model with an offline learning and online prediction. Finally, coming into the potential risks in production that we might see here. First of all, I want to highlight 87% of ML projects are failures as per the VentureBeat 2019 report. Considering that there are some chances that any ML project can fail, and applying the same principle here, let's see how our project can face some problems in the production. So if you look at the 4 main areas, training with serving queue to start with. Here in our case, I don't see training with saving queue is going to be there because we are going to make sure our solution is going to get evaluated in a uh, staging environment kind of thing, where we will have a CI/CD pipeline taking care of evaluating our solution in images before getting into the production. And we are going to replicate the same kind of environment as production in our CI/CDs as well. Latency, again, I don't see any problem with latency in our project because we are going to have everything executed at the edge devices. We have the model already available at the edge device. Scan in metadata is going to be readily available. It is just about triggering the scans and generating the report. So that's not going to impact on the latency side. But getting into the drift side, I think there is going to be a problem on the drift, maybe a data or concept drift. Let me start with data drift. In case of data drift, yes, there might be a possibility that there is going to be a data drift. The main reason here is we are going to perform analysis on possible attacks to the infrastructure, but the nature of the attacks, the way in which the attackers get into the system, the diverse nature of attacks, the different scanners generating different format of reports, all these will be resulting in different data drift. As time goes on, you will see many new things coming in these areas. So there is a definite possibility of data drift. And coming to the concept drift, yes, there is going to be a concept drift. Today, we are relying on the uh, ways in which cyber attacks are injected. The attackers, they try to get into the systems in many different ways. So we will be continuously running our models to cope up with the different types of attacks that are getting injected into the systems. But yes, there is going to be a concept drift considering the different ways and approaches in which the attacks are made in today's environment. So that's about the project that I have here. Thank you very much for your time here.